Okay, so I'm starting with this asymptotes questions based on whatever you sent me. Okay, so let me just talk about what are the asymptotes. Do you have some idea of the horizontal asymptote, vertical asymptote, or should I tell you? Do you have any idea?
Oh,
My screen is visible to you?
yeah.
Okay. So I'm just asking you, just suppose there is a function given to you, there may be some domain A, there may be some range or codomain, whatever you want to use for the moment B there. So we are discussing here two types of asymptote. One is horizontal asymptote
Mhm.
and the another is going to be vertical asymptote. Okay, there is one more asymptote that is oblique asymptote. It will, if it will come into the picture, I will tell you about that. Okay, there is another
Yeah,
type of. Okay, if it is there, then I will tell you, maybe depending upon the question.
okay.
Oblique asymptote. So before giving you anything like how to solve them, let us first try to observe what are the asymptotes we are talking about. Okay, so for this particular case, let me consider a function. Function is going to be 1 over x square. If you ask me what is the graph of this 1 over x square, this is your y-axis, this is your x-axis. So graph will look like this. Okay.
Yeah.
So what you can see, as I am increasing the value of x on the right hand side, this I will represent that x tends to plus infinity. This I will represent it as x tends to plus infinity. When when I increase the value of x, what you can see, there is a branch of the graph trying to touch the x-axis, trying to get close, 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 and ultimate it will not be able to touch, but yes, it will go along this line. Do you agree this is the meaning? So
Yes.
this type of straight line is called an asymptote. It is a straight line along which a branch of curve goes along up to the along this line up to infinity. Okay, they are moving in a direction. So basically straight line is giving you the direction up to infinity. They will try to touch, but they will never able to touch. But yes, the distance between these is going to be less, less, less as you go on as x tends to infinity. Similarly, if you just move to the left hand side, this is where I will be moving towards the left hand side, and I will represent that x tends to negative infinity. That means I'm on extreme left hand side. Okay.
Yeah.
Again, there is a branch of the graph which is trying to touch the x-axis, and but it will never touch. But yes, as x tends to negative infinity, it will try to touch. But in case of never touch, it will go along this line up to infinity. Okay, that means in up to infinity stands for they are going to be companion. So this, because this x-axis is a horizontal line, so we call this as horizontal asymptote. So how to find the
Yeah.
horizontal asymptote? We need to check in case if limit x tends to either plus infinity fx, if it is a constant, or if limit x tends to minus infinity fx is a constant, be there. In this case, y equals to a and y equals to b. These are horizontal asymptotes.
Okay.
Horizontal asymptote. So for example, for the particular question that I have chosen, tell me what if I ask you to take the limit x tends to plus infinity? What will you have? It is 1 over x square.
Um,
It is almost,
why would
yes. Am I right there up to this point?
Yeah.
fx is 1 over x square. It is 1 over infinity square. Infinity square is simply infinity. 1 over infinity of finite upon infinity is going to be 0 for you. So for me, this is y equals to 0 is an asymptote, and y equals to 0 is nothing but the x-axis. Okay. So
Yeah.
x-axis in this case is an asymptote there. You got it?
Okay. Yeah.
Perfectly okay. So look at the same question again, like 1 over x square. If I ask you, tell me a point where the function is not defined. What will you tell me? Tell me a point
Um,
where the function is not defined.
0.
So basically x should not be equal to 0. Am I right?
Mhm.
Is there any other point where the function is not defined? The answer is no. 1 over x square is defined
Yeah.
everywhere. So what I'm asking you, you just look at the graph again. Okay, and you just look at the graph again. Now you need to approach towards x tends to 0. Okay, I should actually move this. Give me a second. Let me just erase this. I should have a better graph.
Also, could I grab my charger real quick?
Please, please.
Okay.
Okay. So now, as I told you, this is the point x equals 0 for you. So whenever you find a point, something like where the function is not defined, you try to take the right hand and the left hand limit at that point. Like I'm asking you, what is 0 plus fx? That means I wish to approach 0 towards the right. When you are looking for towards the right, that means the function value is keep increasing. Am I right? It is
Mm.
keep increasing. It will go up to infinity because it is going higher and higher. So if I
Yeah.
tell you in terms of limit, this is going to be limit x tends to 0 plus 1 over x square, and this is going to be plus infinity. So whenever either x tends to a plus or a minus, depending upon the term, fx is going to be either plus or minus infinity. In this case, x equals to a is a vertical tangent. Is a vertical tangent. Is it clear to you? It's going to be vertical
Yeah.
tangent. There is third statement like the oblique tangent. For the oblique tangent, just suppose there is a function fx there, and you are able to find some values of a and b such that this difference, as you take limit x tends to infinity with a plus minus, it is going to be 0. Let me tell you once more. Fx is a given function. If you're able to identify some a and b such that fx minus ax plus b, limit x tends to plus minus infinity is going to be 0. In this case, this y equals to ax plus b is a asymptote. Sorry, I made a mistake. It is asymptote. Sorry, it should be asymptote.
Mhm.
Is a oblique asymptote. Okay,
Okay.
let me give you an example there. How to identify this type of question. Generally, consider a case fx which is equals to x cube over x square plus 1. You can take plus 1 whatever the function. The idea here
Mhm.
is the degree of numerator is going to be degree of denominator plus 1. So there will be a difference of only 1. Like the degree of numerator is 3, the degree of denominator is 2. Try to help me with the division
Mhm.
you have. Please help me with the division. So I write x, it is x cube plus x. Subtract them. X cube will cancel out. You will be having negative x. So that means to say the right hand side can be written as x minus x upon x square plus 1. Do you agree?
Yeah.
Just long division. And the observation should be the degree of numerator is going to be 1 plus the degree of denominator. And it is rational function. So just try to just transfer this x on the left hand side. So it is fx minus x. On the right hand side, I will be having negative x upon x square plus 1. Agree?
Yeah.
Now I'm asking you, what if I take limit x tends to infinity fx minus x? So keep the negative out. I will be getting limit x tends to infinity x upon x square plus 1. Agree?
Hmm.
I'm just applying x tends to infinity. Now you can observe if you put infinity, it is of infinity over infinity without any issue. If you put infinity in place of x, in the numerator you will be getting infinity, denominator is also infinity. But fortunately, they are going to be very easy for me. Whenever infinity over infinity structure is there, and it is a rational function, I am going to divide the numerator denominator by the highest exponent of x, which is going to be x square. So divide the numerator by x square and divide the denominator by x square. Any doubt?
Okay.
Because
No.
x square was the highest term in the numerator denominator. So the numerator becomes limit x tends to infinity 1 over x. It is going to be 1 plus 1 over x square. Any doubt?
Mm.
If up to this point everything is okay, remember, if there is a finite term, dividing by infinity, whether it is positive, negative, hardly matter. It is going to be 0 for you.
Oh,
Okay. So why I'm telling you this? Because you are having terms like 1 upon x. When x is infinity, this is going to be 0. And 1 upon x square, when x tends to infinity, it is also going to be 0 for you. So you please help me in just writing the limit. Okay, I need to just put the values. This is going to be 1 over infinity, numerator is 0. It is 1 plus denominator is 0. Technically, right hand side is 0. So just look at the statement what you obtained. There was a function fx given to you. I'm able to get a straight line expression ax plus b. A is 1, b is 0, such that in case of limit x tends to infinity, I'm getting 0. Am I right? This is what I have obtained. Right? Are you there? Hello, are you there?
oh yeah, I'm there.
Okay, so
Um,
up to this point, are you able to understand that fx minus ax plus b in case of limit x tends to infinity is 0?
yeah.
And that means to say that the straight line y equals ax plus b. In our case, it is going to be x. It is going to be an asymptote.
Hmm.
Okay, so this is how we should be able to find the asymptote. So now let us just focus on the questions given to you. Okay, let me just download the PDF first, and then after I'll get those questions. Give me a second. So let me just paste the question here. The first question is, read the question carefully. Find all key pieces of this one. They are looking for vertical asymptote, horizontal asymptote, and whatever left. By default, I will be representing it by fx. Okay,
Hmm.
and just try to help me with fx and look at the denominator first. Denominator is going to be how much? If I'm writing like the factorization basically, x minus 5, x plus 5. Am I right?
Yes.
Okay, numerator, I do not need to factorize, but still, if I can do, it will be good for the observation purpose only. So I'm taking x common in the numerator. Can you please help me with the factorization of the numerator? Denominator was an obvious task. 10
It'd be x,
minus 5,
x,
x
yeah,
plus 2.
minus 2.
Am I right?
Oh, yeah, sorry. Plus 2. Yes.
So what you should observe that there are terms like x minus 5 in the numerator and denominator which may cancel out. In this case, whenever there is a common term in the numerator denominator, x equals 5 is not going to be a vertical asymptote. Okay, x equals to 5 is not going to be a vertical asymptote. So now let me just start with some questions there. State the domain. The domain is the set of all real numbers. The domain is the set of all real numbers except where the denominator is 0. The denominator is 0 at negative 5 and 5. Any doubt?
Mm-hmm.
Okay. So we will be talking about the slant asymptotes. Okay. X and Y intercept. So whenever a situation like this is given to you, so if I ask you X intercept, you need to put the dependent variable y equal to 0. That means fx equals 0. Whenever it is a rational function given to me, fx equals to 0 stands for at what point the numerator is going to be 0.
Mm-hmm.
Can you please help me? Numerator is 0 at x equals
0,
0,
at 0, 5,
5,
and
and
negative 2.
negative 2. But I'm rejecting 5 there. Why? Because the function was not defined at
Oh, because it canceled.
yes. So you need to reject that point. So you get the x-intercept without any issue. Okay. Tell me
Mm-hmm.
what about the y-intercept? In order
Then
to
x
get that,
would be 0.
yes, you need to put x equals 0 and solve for y. Okay. So if you put x equals to
Mhm.
0, because of this term x, I hope the right hand side is obviously 0.
Yeah.
Okay. So I have got the intercept, x-intercept, y-intercept without any issue. Now let us talk about the vertical asymptote and horizontal asymptote. Uh, I told you if you look at the denominator, most of the time the points where the denominator is 0, those points are going to be vertical asymptote in case of rational function. But yes, there is a factor which may be cancelled out. So that means to say that only term which may be going to be vertical asymptote is this term. So for me, x equals negative 5. For me, this x equals negative 5 is going to be vertical asymptote. Do you agree? Only one term contributing vertical asymptote. No doubts?
No.
Perfectly okay. So let us now talk about the horizontal asymptote. Give me a second and let me just take the screenshot once more. Yes. It is a rational function, so it is easy to identify the horizontal and the oblique asymptotes. Let me just consider this as fx. In case if degree of numerator is equals to degree of denominator, in that case, if you apply x tends to infinity fx with the positive negative sign, maybe this may be equal to a finite number. Okay, in that case only, if it is finite, say it is equals to a, in that case your y equals a is going to be a horizontal asymptote in case the degree is equal. But if the degree is not equal, okay, but that I should use the word just a second. Degree numerator degree is going to be less than equals to yes. This should be the correct wording. If it is either less than or equal to degree of denominator, then y equals to a is an asymptote. So certainly, whenever degree of numerator is bigger than degree of denominator, in this case there is no horizontal asymptote. So why I'm telling you this? Because I can observe the degree of numerator is 3 there. Degree of denominator is going to be 2. So certainly there is no horizontal asymptote. If the degree of denominator is either equal or bigger, in this case, yes, there will be a horizontal tangent. How can I verify this statement? I'm just asking you to apply limit x tends to infinity. Tell me if it is going to be finite, then we have a horizontal asymptote, otherwise no. So how should I do this? This is going to be infinity over infinity structure. Yes or no? Vidya, yes.
Yeah.
Is it going to be infinity over infinity? Check. If you place infinity, it should be. If you place infinity in place of x, what will you have because of this? It is infinity cube. Am I right? That is infinity. In the denominator, what you have? Infinity. So basically, it is infinity over infinity term. Always remember, whenever we are working with the rational terms, so we need to focus on this type of statement, infinity over infinity structure, if it is available. In this case, what I told you, what is the maximum exponent of x? X cube. Divide each term by x cube in the numerator and the denominator also. Do you agree what I'm doing? Dividing each term. So I'm just writing x square by x cube minus 25 divided by x cube. Cancel out the terms. Limit x tends to infinity. This is going to be 1 minus 3 over x, 10 over x square, divide by 1 over x, minus how much it should be? How much it should be? 25 over x cube. If I ask you to apply infinity, numerator is 1, minus 0, minus 0. Am I right? 3 upon x is 0 because 3 upon infinity is 0. Denominator is going to be 0 minus 0. So it is 1 over 0, which is does not exist. So in this case, because 1 over 0 does not exist, in this case, there is no horizontal asymptote. Even if you apply positive negative sign, in this case also there is no because the limit is not finite, so there is no horizontal asymptote. Okay, so you need to focus on this and how we can identify directly. Just look at this statement. Whenever degree of numerator is less than equals to degree of denominator, there is a chance that we will be having a finite limit and we will be having a horizontal asymptote. So no horizontal asymptote. Now just let us do one more calculation. I need to find out what is going to be the oblique asymptote. So for oblique asymptote, let me just take you to a similar situation like we have discussed in the beginning. Numerator is bigger than denominator in terms of degree, and the degree is just plus 1. Please help me in division. X cube minus 3x square negative 10x. And I wish to divide by x square minus 25. Let me just try for with x. It is going to be x cube minus 25x. Subtract. So x cube will cancel out. So I will be having negative 3x square and it is positive 15x. Again, just try to have negative 3. So it is negative 3x square negative and then after negative positive 75. Change the sign. So these two cancel out. You will be having 15x minus 75. This is your remainder. Any doubt? So that means to say that this function fx is going to be equal to quotient is x minus 3. Remainder is 15x minus 75 divided by x square minus 25. Do you agree?
Yeah.
If no confusion is there, let me just write down them like transferring x minus 3 on the left hand side. Right hand side will be having divide by x square minus 25. Right?
Mm-hmm.
I'm asking you now, please help me. X tends to, you need to just take the limit infinity, fx minus x minus 3. You need to apply limit x tends to infinity on the right hand side also. Right?
Mm-hmm.
So if I ask you to put infinity in the numerator, you have 15x, it is infinity. In the denominator, you have x square. So basically, I'm having an infinity by infinity structure. Right?
Yeah.
How should I simplify this? Just divide by the highest degree term, like x square in the numerator, 75. Each term I'm dividing by the highest exponent of x available in this expression. It is x square.
Mm-hmm.
When you simplify, limit x tends to infinity, this is going to be 15 upon x minus 75 upon x square divided by 1 minus 25 upon x square. Now the terms are easy for me to calculate. If I plug infinity in place of x, 15 upon infinity is going to be 0. 75 upon infinity is going to be 0. Denominator is 1 minus 0. That is simply 0. Do you agree?
Yeah.
And because this limit is 0, that means to say that y equals x minus 3 is an asymptote. Is an asymptote. We call it oblique asymptote.
Okay.
Okay. So this is what we have got and like an expression for you. Okay.
Okay.
There is something written like holes. What they are expecting for us, like what is the situation?
Like ordered pair notation.
Ordered pair and holes. Okay.
Like for the X value.
Sorry. Basically, I'm not able to get this statement holes. Let me just check what is the meaning there. If I can understand the meaning, then I can tell you. Okay. For the time being, let me just take you to the next bonus note on quiz. When is the function is going to be less than equals to 0? This is the question. Let us just try to solve this question. Okay.
Okay.
Try to help me. The function was, and we have factored the function. It was x minus 5, then x plus 2, divide by x minus 5, and x plus 5. Do you agree?
Yeah.
So you need to tell me points where the function is either 0 or not defined. So I'm asking you about the critical point. Critical points for me for this timing are the point where either the function is 0 or it is not defined. Can you please help me?
Okay.
So x equals
And
0, it is 0. X equals minus 2, it is 0. X should not be equal to negative 5, and x should not be equals to 5 because these points are not included. Am I right?
mhm.
So help me in just denoting on the real line. Negative 5, negative 2, 0, and 5 there. Let me tell you that point negative 5 is not included. Point 5, it is not included in the domain. Right?
Okay. Yeah.
So we have up to infinity minus infinity. So our objective is to check the behavior of the function where it is going to be negative. This is the objective, am I right?
Mhm.
So for this purpose, we will be choosing test values. Test values. Okay, test values are some values which may be just randomly chosen in the interval. From 5 to infinity, can you please choose the test value of x? 10 there?
6.
6. Okay. Let me just choose 10. No to issue. From 0 to
Yeah.
5, can you please choose a test value? 1
3.
or 3? We just take 3 there. Okay. From -2 to 0, choose a test value.
-1.
-1. Can you choose a test value here?
-3.
-3 there. Okay. Can you choose a test value here?
-7.
Negative. -7. Okay. So
Yeah.
up to this point, I'm just asking you just once more. Give me a second. Yes. I need to check the. Give me a second. Someone is texting me. Okay. Yes. Sorry. So basically, x equals 0 minus 2. So there was a function given to me. It is a rational function. I just factorized, just try to find out the point where either the function is 0 or it is going to be not defined. Okay. I have got the test values. Let us start with the test values. I'm talking about 5 to infinity. Tell me what is f10. I'm not asking you about the value. I need the sign only. So it is going to be 10. 10 minus 5 is 5. 10 plus 2 is 12 there. Divide by 10 minus 5 is 5 there. And it is 15. So the answer is going to be positive. Wherever it is positive, it is increasing. Sorry, not increasing, it is going to be positive. So basically in this interval, the value of the function fx, it is always positive. So it is not of my interest because I need to find the interval where it is decreasing. Do the same exercise with f3. So I'm writing 3, 3 minus 5 minus 2, 3 plus 2, 5 there. And this is 3 minus 5 is going to be minus 2. Okay, and 3 plus 5 is 8 there. The sign is going to be positive again. So that means the function is positive here also. Do you agree?
Yeah.
Okay, can you please help me with this calculation? Tell me what is the sign of f minus 1?
That would be that'd be positive.
That will be positive. Let me check. -1, negative.
Or no, it'd be negative.
It is 1 there.
Negative.
Then after it is -6 there. Then after it is 4, it is going to be negative. So that means the function fx is going to be less than equal to 0. Okay, remember, we are going to use less than equal to 0 whenever the endpoints are in the domain. So because the function is defined in the at the point like 0 and -2, I can use this expression. Can you please check the same for f minus 3 and f minus 7? Just do the calculation. Tell me with the values.
For -3, it would be positive, and then for -7, that would be negative.
So f minus 3 is going to be negative.
Negative.
Are you sure?
That would be positive.
Positive.
-7 is negative.
So it is going to be positive. So you are telling me it is positive there. Okay. So oh, tell me f minus 7.
That'd be negative.
That will be negative there. Are you sure?
Mhm.
Perfectly okay. So I'm just counting on you. I have not calculated. So it is going to be fx less than equal to 0. So look at the picture. That means to say that whenever x belongs to minus infinity to negative 5, and this negative 2 to 0, the function value is negative. Am I right?
Mhm.
Now, I'm including minus 2 and 0 because these are the points in the domain. And minus infinity is not in the real number, so you need to use open interval there. The function is not defined at minus 5, you need to use the open interval. So this is the set of points where the function value is negative. Any doubt?
Okay. No.
Okay. So let me just, if is there any issue in any of the situation?
No.
Perfectly okay. Now let us just go to the next question. The concept of whole, I need to check what they mean by the concept of whole. Then after I can get back to you. Other than that, now for the question above, describe the using limit notation and behavior. The meaning of and behavior is going to be whenever you use x tends to infinity, fx, what is going to be the value, and what if you take x tends to minus infinity. So whenever you are able to identify these two limits, whenever you are able to identify these two limits, these are going to be AND behavior. For the particular question we are discussing, because there was no horizontal asymptote, it may be plus minus infinity. In the previous case, it was plus minus infinity. So basically, they are increasing or decreasing depending upon the sign of infinity. If it is positive, it is increasing, okay? And if it is negative, it is decreasing without limits. Any doubt?
Okay. No.
So I have given you an idea how to take the limit. Am I sure? So sorry, are you
Yeah.
sure? Let me just show you. Yes, I have taken the limits, and this is using the limits I told you. And other than that, by looking at the behavior, I told you when there will be asymptote, when there will be no asymptote. Okay,
Yeah.
horizontal asymptote. Now we talked about the vertical asymptote also by looking at the expression. I told you that x equals to 5 is going to be vertical asymptote. Oh, sorry, I made
Mhm.
a mistake. It was negative 5. It was negative 5. Okay, it was negative 5 there. So that was a correction. And whole, I need to find out the meaning of whole here. I'm not able to relate this point. Yes, this whole
What is
y-
it's when like there's like a certain point on like the graph that like there's it would be undefined.
okay. So let us just leave this point for the next class. Meanwhile, you just send me any of the working of your teacher. I'll just read that, and then after I'll discuss with you. Okay, so that there should not be any mistake from my side. It is better to do tomorrow. Look at the question and just pasting the graph there. Okay, you look at the graph. So certainly by looking at the graph, like you were telling me, there is a point where the function is not defined. It is an open circle. I hope you are referring this point as a whole there.
Yeah.
Am I right? Okay.
Mhm.
And there is a vertical line given to you. Whenever you see a vertical line like this vertical line is going to be vertical asymptote.
Okay.
So it is was 1, 2, 3. I can tell you that x equals to 3 is a vertical asymptote. Can you tell me any other vertical asymptote?
X equals 0.
X equal to 0. Perfectly okay. The branch of the graph of the function goes along with the straight line up to infinity. Okay, so now you can see that there is a x-axis and this branch of the graph trying to touch the x-axis, but it will never, but it will go along this up to infinity. So certainly y equals to 0 is going to be horizontal asymptote.
Okay.
Clear? Write the equation of the graph in factored form. Assume any vertical dilation is 1. Okay, you need to just tell me the factors basically. So now please try to help me. There are two vertical asymptote. One is x equals 0 there, one is x equals 3.
Yeah.
Vertical dilation is 1, so I'm expecting that x and x minus 3 is in the denominator. Agree?
Mhm. Yeah.
Okay. Next question. What should be in the numerator? Just a second. Let me just. There is a hole at this point. What is 2 there? So I'm expecting that I'm getting x minus 2 in the numerator denominator. Okay. If this is the sense of hole, I can tell you that x equals to 5 is a hole there. Because I told you
Mhm.
x minus x 5 will cancel out. So x equals to 5 is going to be a hole for you. Okay.
Yeah.
So because it is a whole, so there must be a factor in the numerator denominator that will be cancelled out. Uh, any vertical dilation is going to be 1. So I have considered this. Anything else? Give me a second. Do I need to tell you anything? I think that is all I can help you. So now if you ask me vertical asymptote, these two will contribute to the vertical asymptote without any issue. This
Yeah.
x minus 2, it will contribute to whole there. And let me just ask you, what is the degree of numerator? Is it 1?
1.
Is it less than degree of denominator?
Yes.
So in this case, you will have a horizontal asymptote. Horizontal
Mhm.
asymptote. And that is going to be 0, where it will get 0, y equals 0. If it is less than, certainly it is going to be y equals to 0 there. If there is an equality sign, there may be a non-zero value, depending upon the situation. Any doubt in the question? Okay. I hope I am correct up to this point. Please try to help me with the next question. That means for these type of question, you need to factorize the numerator denominator for a better understanding. Look at the question, please. Given hx equals x square minus 4 divided by this term, the factors of numerator should be x minus 2 and x plus 2. Do you agree?
Yeah.
In the denominator, you can see the factors are x plus 2, 5 and x plus 2. So certainly I can cancel out x plus 2 there without any issue. Right?
Mm-hmm.
Perfectly okay.
X equals -5, -2
So
would be a whole, right?
x equals negative 2 is going to be a whole because of this reason. Okay.
Mhm.
Vertical asymptote. So I can tell you that x equals -5 is going to be vertical asymptote. If you ask me about the domain is going to be from the real number. You need to subtract where the denominator is 0, that is -2 and -5. Any doubt here?
No.
Okay. Next question is okay. Find the whole using limits. Okay. So using limits basically. So I will be checking what is going to be x tends to -2 fx. Okay. Uh, so this is going to be our limit x tends to -2. I'm just talking about the whole first. The point.
Mhm.
It is going to be x minus 2 divided by x plus 5. And I forget to write x plus 2 in the numerator denominator. And both cancel out each other. So now just plug the value. It is going to be -2 divided by -2 plus 5. So I will be having -4 by 3. Any doubt?
Mhm.
So
No.
at x equals -2, the height is of the hole is going to be -4 by 5. Now you need to find the vertical asymptote. For vertical asymptote, I'm just requesting you to try x tends to, and this is a -5 positive. Okay, so x minus 2, x plus 2 divide by x plus 5, x minus 2, x plus 2, sorry. These two cancel out without any issue, so I'm not interested there, and I can remove them. Okay. Now, I need to check the sign only. Certainly, denominator is 0. Am I right?
Yep.
This minus 5 is somewhere here. Choose a point that is close to minus 5. Can I choose?
No, you're safe.
From the plus stands for from the right, and negative stands for, so I'm choosing negative 4. Just place the value of x minus 4. Tell me what is the sign. Just place the value x equals minus 4. What is the sign there? Is it negative? So technically it is going to be negative infinity. So that is why it is going to be an vertical asymptote. Do you agree? Okay. Let me tell you, if the question, and you can also check x into negative 5 minus, expression is same. Now I will ask you, choose a point that is on the left of negative 5. In this case, you should choose negative 6. This is going to be, the sign is positive, so I will be having positive infinity. So x equals minus 5 is going to be vertical asymptote for you. Okay, and how to check the sign, I told you. Any doubt? Next question. Okay. Yes. When the function is going to be bigger than 2. These type of questions are very easy. Let me just tell you. So in order to solve these type of question, my function was hx, sorry. It was x square minus 4 divided by x square plus 7x plus 10 bigger than 2. So I'm subtracting 2 from both sides. And ultimately, I will be using factorization technique like I used earlier, using the test, and after that, test values. So x square minus 4, if you take the LCM, it is negative x square negative 14x and negative 20 divided by x square positive 7x positive 10. Am I right? Can you simplify the numerator? X square cancel out. Is it going to be negative 14x negative 24? The denominator is going to be how much? It is going to be the same, positive. It is going to be the same, x square plus 7x, that is, if you just take the factors, x plus 2, x plus 5. Somehow, can I factorize the numerator? Just take negative 2 common. It is 7x plus 12. And the denominator is going to be x plus 2, x plus 5. Any confusion up to this point?
No.
No confusion. Perfectly okay. Now, I need to know the points where the function is either 0 or not defined. So x equals minus 2 is a point where it is not defined. X equals negative 5 is also a point where the function is not defined. And x equals to negative 12 by 7 is a point where the function is 0. So minus 2, the function is not defined. Minus 12 by 7. Another is going to minus 5. Okay, so minus 5 should be somewhere here. Any confusion up to this point?
No.
So there will be 3 intervals you will be having. Choose a test value here. Can I choose x equals 0 test value?
Yeah.
Help me with any test value. I hope minus 1 is going to be in between. No, just a second. 12 by 7 is going to be 1 point something. Am I right?
Yeah.
It's going to be 12. Can you please tell me any test value that may be in between negative 12 by 7 and negative 2? Certainly it is not going to be minus 1.
Yeah, it could be negative
Use your calculator.
1 and 6 over 7.
Yes, use your calculator, you can tell me. X equals -5, -2. Let me choose -4 there. And let me choose -6. Okay. This expression, let me assume this expression is gx. Can you tell me what is the value of g at 0? What is the value of g at the second test value? -4. What is the value of g at -6 there? And this point, just a second, let me just choose 1.9 with the negative sign. Okay, you can use the calculator without any issue. So you need to just choose the values and try to tell me the values. So I'm expecting that this is going to be negative sign, and this is going to be positive sign. This is going to be negative sign. This is going to be positive sign. Can you please verify the facts? Or I can leave them as a homework for you to test. Will you be able to get the value of g's? Okay, if it is correct, I need the values where it is positive. So basically, my gx, my hx bigger than 2 is equivalent to gx bigger than 0, implies that x belongs to which interval? It is -5 to -2, first interval. And the second interval is going to be how much? -12/7 to infinity. Because the sign is strict, you will not be using the endpoints. Sign is strict, you will not be using the endpoints. Any doubt?
Okay.
So my request to you, that this is the end of the